Here we have a problem on derivative. Okay, let's go to the question. If y equals to square root of 1 negative x over 1 positive x, show that 1 negative x square times dy over dx positive y equals to 0. Okay, here we have a function and we have to prove this result. Okay, so to prove this result, I need dy over dx. That is, I have to find derivative of this function with respect to x. Okay, now let me take the given function as it is. It is y equals to square root of 1 negative x over 1 positive x. Okay, now to get dy over dx, I have to find derivative on both sides of this equation with respect to x. When I find derivative of this y with respect to x, I'm getting dy over dx. That's exactly what I have over here. And how can we get derivative of this one? So here first I have to do derivative for the square root. For that we have to try the square root as exponent 1 over 2. So once I'm done with the derivative for the exponent 1 over 2 using power of derivative, I have to do further derivative for the stuff inside the square root using chain rule. When I try to find derivative of the stuff inside the square root using chain rule, so I have to use a coefficient rule because we have variable in both numerator and denominator. So to avoid all these complications, so what we can do is we can do logarithmic derivative. So that is, we have to take a logarithm on both sides. When I take logarithm on both sides of this equation, I can use the properties of logarithm as much as I can. When I use the properties of logarithm, I'll be able to get up this square root, and also I can avoid this rational function inside the square root. I think I'll be able to split up the function into parts. When I split up the stuff into parts, the process of finding derivative will become easier. So that's the advantage of taking logarithm on both sides. Okay, so when I take logarithm on both sides, it must be natural logarithm because the derivative will work only with natural logarithms. Okay, now let me take natural logarithm on both sides. Then I'm getting ln of y equals to ln of square root of 1 negative x over 1 positive x. Then we get ln of y. Now let's use the properties to split up this one into parts. So our first work is to write this square root as exponent. When I do so, I'm getting 1 negative x over 1 positive x raised to the power of 1 half. Whenever we write square root as an exponent, the exponent will be 1 half. Okay, now let me use the properties of logarithm. Now I'm going to use the power rule of logarithm. So because my aim is to get this exponent 1 half. So power rule of logarithm means whenever the argument of a logarithm is a power, then the exponent we have at the argument of the logarithm can be moved in front of the logarithm. This is called the power rule of logarithm. So now we can move this exponent 1 half that we have at the argument of the logarithm in front of the logarithm. Then we get 1 half times ln of 1 negative x over 1 positive x. Okay, in my next step, what I'm going to do is I'm going to use the coefficient rule of logarithm. That is, whenever two quantities are division in the argument of the logarithm, what I can do is I can take logarithm of the numerator and denominator and subtract the results. Okay, let me do it. Then I'm getting ln of y equals to 1 half times. Now I have to take logarithm of the numerator, that is ln of 1 negative x negative ln of the denominator, that is 1 positive x. Okay, so here I use the coefficient rule. Now what we can do is that's all we can use. I mean, that's all the properties of logarithm we can use in the given function. Now we can start finding derivative. So let me write the stuff over here. Differentiate both sides with respect to x. Because according to the information, we have to find derivative on both sides. We have to find derivative with respect to x. Okay, so here first I have to do derivative for the stuff on the left side, that is ln y. When I find derivative of natural logarithm, what I have to do is first I have to write 1 in numerator, and the argument of the logarithm should be written in denominator. So far I have computed derivative only for the natural logarithm on the left side. By chain rule, I have to further derivative of this y with respect to x. When I do so, I am getting dy over dx. That is the derivative of y with respect to x is dy over dx. And here 1 over 2 is a constant. It's multiplied by the variable part. Since here we have variable, here we have variable, the whole stuff has to be considered as a variable. Now the constant 1 over 2 is multiplied by the variable. When I find derivative, if there is a constant multiplied by the variable part, the constant should be kept as it is. I have to find the derivative of the variable alone. Okay, now when I find derivative of this natural logarithm, I have to write 1 in numerator, and the argument of the logarithm has to be written in denominator. Okay, now I have completed derivative only for this natural logarithm. By chain rule, I have to further derivative of this 1 negative x. So when I do further derivative of this 1 negative x, particularly for this constant 1, it will become 0. When I find derivative of this negative x with respect to x, it will become negative 1. Let me write the negative sign. Now, the same thing, when you find derivative of this natural logarithm, I have to write 1 in numerator. The argument of the logarithm should be written in denominator. By chain rule, when I do further derivative of this 1 positive x, this 1 will become 0 because it's a constant. The derivative of x with respect to x is just 1. 1 over y times dy over dx equals to 1 over 2 times. Okay, when I multiply this 1 and negative 1, I'm just getting negative 1 over 1 negative x. Negative 1 times 1 is 1 over 1 positive x. Then we get 1 over y times dy over dx equals to 1 over 2. Now we have to simplify this expression. So what we can do is we can consider the two denominators over here. Because we subtract two fractions, if the denominators are same, we can easily do subtraction, but the denominators are different, 1 negative x, 1 positive x. So now what I'm going to do is I'm going to use cross multiplication. That is, the first numerator has to be multiplied by the second denominator, and the second numerator has to be multiplied by the first denominator. Okay, when I multiply this negative 1 and this 1 positive x, I'm just getting negative 1 times 1 positive x is the same 1 positive x. Okay, now let me take this negative sign as it is. When I multiply this 1 negative x and 1, that is 1 times 1 negative x is the same 1 negative x. Now we have to multiply the two denominators, that is 1 negative x times 1 positive x. Let me write out here. Okay, now 1 over y times, let me write it, dy over dx equals to 1 over 2. Here we can distribute the negative sign to this 1 and positive x, and I'm getting negative 1, negative x. When I distribute this negative sign to this 1 and negative x, I'm getting negative 1, positive x. Here we can consider the product of the two binomials over here, 1 negative x times 1 positive x. It's in the form of a negative b times a positive b. So I consider the product of the two binomials. Okay, whenever we multiply two binomials in this form, a negative b times a positive b, so it results a square and negative b square. So here at the place of a, we have 1. At the place of b, we have x. So for a square negative b square, what I have to do is I have to write 1 square negative x square. Here I can cancel this negative x or positive x. Then let me continue on the next page. Then we get 1 over y times dy over dx. On the right side, we have 1 over 2 times. So here, when I combine this negative 1 and negative 1, I'm getting negative 2. So negative 2 over, we have 1 square negative x square. I think this 1 square, we can just write 1 because evaluation of 1 square is just 1. So we get 1 negative x square. So here this 2 will cancel out. That is 2 goes into 2 one times and 2 goes into 2 one times. Then we get 1 over y times dy over dx equals to negative 1 over 1 negative x square. Okay, now to solve for dy over dx, I have to get up this denominator y. For that, what I have to do is I have to multiply both sides of this equation by y. Okay, let me do it. Y times 1 over y times dy over dx equals to y times negative 1 over 1 negative x square. So here this y will cancel out. Then I'm getting dy over dx equals to y times negative 1 is just negative y over 1 negative x square. Okay, here I got the result for dy over dx, but when I look at the result given in the question here, this dy over dx is multiplied by 1 negative x square. So now what we can do is we can multiply both sides of this equation by 1 negative x square. Okay, let me do it. Let me multiply the stuff on the left side by 1 negative x square, the right side by 1 negative x square. So here this 1 negative x square in denominator, this 1 negative x square will cancel out. Then I'm getting 1 negative x square times dy over dx equals to, on the right side we just have negative y. Now let me add y to both sides. When I do so, this negative y positive y will cancel. Then I'm getting 1 negative x square times dy over dx positive y, because here we have added y, positive y equals to 0. Okay, now I have shown the expression that is 1 negative x square times dy dx positive y equals to 0 as given in the question.